Let's get started, people. So we are going to use some of the information we already know and introduce some geometry to it. We're all very excited. So when it comes to finding the derivative, what are we using that to do? You did not listen to my question. Right, we're finding gradients at certain points. So we have found things before in geometry, and we're going to now use derivatives to help us do that better. What is something we found when we had curvy graphs earlier? What is something we were finding in relation to those? We have never done that before in geometry. So that's with T. It's not the turning point, but that is something we can do with the derivative. We've never done that. So what is there's a special kind of line that starts with T that we've been finding, tangent lines, right? So we've been finding tangent lines, which are lines that touch a curve or a circle. We've done it with circles, but don't go into the circle or into the shapes. So we can find, so I'm going to introduce a new, actually, let's not clear that yet. I'm going to introduce a new word to you today, and the word is normal. So if this is a tangent line, do you know what it is? What's a normal line?
It's probably
Good. So a normal line is perpendicular to the tangent. So we call this the normal. So if you're asked to find the normal at a particular point, you may need to find the tangent first, because if you know the tangent, do you know the gradient of the normal?
Yeah.
What is it?
Oh, negative 1
Okay, so the inverse reciprocal, right? So negative 1 over m. Okay, so if the tangent line is 2/3, what's the normal tangent gradient?
M over.
-3 over 2.
Okay, -3/2. All right, so we flip it upside down, change the sign. Okay, so if this one is -2, what's this one? +1/2. Good. All right. So anytime you see the word normal, you're being asked to find a line that is perpendicular to the tangent. Now, we've done this before. We've just never used derivatives to do it. So finding a derivative is going to help us find the gradient at a certain point, right? Because that's the information we're not going to have. How do you find the general equation of a straight line? Okay, so y equals mx plus c. And so that's the general equation of a straight line. But what is I think you were saying it maybe, Adil. What was it? Good. Perfect. So we're going to use this a lot. Okay, so this little formula is really going to help us. We're going to need the gradient, and we're going to need a point, and we're going to be asked to come up with equations of both tangents and normals. Sound all right? All right. So let's do a couple of examples of this. So we've done all this before, but now we're going to do it using derivatives, and we're going to show you why it's actually useful. So I've got y equals 2x squared plus 8 over x squared minus 9. So I want to find the equation of the tangent. So let's make that A. And I want to find the equation of the normal. And I want to do that when, for both of them, x equals 2. All right, so the first thing I'm going to need to do, so to find an equation, I'm going to use this lovely little thing that we just talked about. But I need to find, first of all, what is y at this point? That's pretty easy. If I just say y equals 2 times 2 squared. Actually, I don't think I do need to do that. I don't even need that information. Oh, yes, I do. Okay. Plus 8 over 2 squared minus 9. So we've got 8 over 8 over 4, which is 2 minus 9, which is 1. So that means the point here is 2, 1. Good? So now what we need to do is find to find the gradient so we can actually find these equations. So I'm going to do that by finding the derivative. All right, let's change colors. So let's make this red. Okay, so I've got y is equal to 2x squared. I'm going to rewrite this as a negative power so I can differentiate, right? We always want to do that. So then what is the derivative of this? What have I got? 4x? Good. All right. And this bit just disappears. Okay. So this is my lovely little derivative. Now, what do I do? If I need to find my gradient, what would I do with this? I shouldn't have gone that far down. What should I do with this? Replace x with what? Good. So I want to know what is the gradient at this point. So I'm going to make x equal 2. I'm going to rewrite this as I do it. So I've got 4 times 2 minus 16 over 2 cubed, right? Because this belongs on the bottom of an equation. So let's scroll back down. So we've got some room. So then we have 8 minus, this is 16 divided by 8, which is 2. So the gradient is 6. So that means the gradient when x is 2 is 6. Now that's great because that means I can now find my equation. By doing this, I can say that y minus y1 is 1 equals m, which I just found out was 6, x minus x1. So y equals 6x minus 12 plus 1, y equals 6x minus 11. That was written really badly. That is the equation of the tangent. Now it's really easy for me to do let's move it, exactly the same thing with the normal. So let's color this green. So to do things for B, I've got exactly the same information. I know that the point is 2, 1, and I know that this gradient was 6. So what's this new gradient? Careful. Negative 1 over 6, right? So then I've got y minus y1, these are exactly the same, equals m x minus x1. So y equals negative 1/6 x plus 1/3 plus 1. So y is negative 1/6 x plus 4 over 3. All right, does that make sense? So this bit's the easy bit, right? You just need to change the gradient. It's getting the gradient in the first place that is a little bit fiddly, that requires just a handful of things. All right, let's do a little bit of a harder example.